Now, the weight of the solute is represented by W2. Please make a note. And what about weight of solvent? W1. Molar mass of solvent is represented by M1 and solute is M2. So this is W2 is weight of solute. W1 weight of solvent. So this is solute and this is solvent. Then we have N2, number of moles of solute, number of moles of solvent. We know number of moles is equal to weight by molecular weight, right? Therefore, number of moles of solute is equal to W2 divided by M2. Got it? Therefore, N2 similar to N2, N1 is equal to W1 divided by M1, right? So W1 divided by M1. What is W1? Weight of solvent. M1 molar mass of solvent. Now, let me explain about the concentration. Some mass of solute dissolved and made up into solution is called concentration. Is it not? Some weight is present in a given amount of solution. So, this can be expressed in terms of percentage. In that case, we can have weight by volume percentage and then volume by volume percentage. Then we can have weight by weight percentage also. And another expression for concentration is molarity. M represents molarity. M is given as molarity. Then you have another term called normality. N, capital N, normality. And then you have mole fraction. You can put mole fraction of solute. Then we have another term that is molality and parts per million. So likewise, the concentration can be expressed in many ways like percentage, molarity, normality, mole fraction, molality and parts per million. In fact, here you need not have any basic knowledge about the molecular formula, molecular weight, etc. So industrial people, they can work out based on this. But here you should be aware of molecular formula because it involves a molecular weight. Now, W by V percentage is given by weight of the solute divided by volume of the solution into 100. So here V is in milliliter, that is volume of solution, not solvent, solution. Then W2 is the weight of the solute in gram. Into 100, that indicates the percentage. Then weight by weight percentage. This is given as W2 by total weight of the solution. That includes the solute and solvent. So you can indicate this as W is equal to W1 plus W2. What do you understand from this? It is the total weight of the solution. That is W1 and W2. Then we have into 100. Now what about this one? This is in gram. This is also in gram. Then third, weight by volume. So this weight by volume volume by volume percentage is given as, that is volume of the solute divided by volume of the solution into 100. When you talk about the solution, it can be a solid solution, solid liquid solution, liquid solution, gas liquid solution. So there are many types of solution. So in the case of solid solution, you can consider this. In certain cases it is given in solid liquid solution also. In this case also this is solid liquid solution because volume is included. In this case liquid in liquid, that is liquid solution. For example, milk mixed with water or water mixed with milk, vice versa. Okay? So by applying this formula, you can straight away get the results very comfortably. And here V is the volume of solution in ml. What about this? This is the volume of the solute, that is in the liquid form, is in ml. Okay? So we have completed this one. Now let me talk about the molarity. Molarity is given by N2 by V. I go by the symbols and terms so that you can easily remember and make use of all this formula in your problems. So what is the N2? N2 we know, which is nothing but W2 by M2. So W2 by M2 into 1 by V. Where W2 is given in terms of gram and the V is given in terms of liter. That you should remember, liter. Then what about this molar mass, gram per mole? So these are the units you should remember. Now normality. Normality is given as equivalent of the solute divided by volume of the solution in liter. Volume of the solution in liter. And equivalent is nothing but, for example, in this case you call it mole. What do you mean by mole? The molecular weight expressed in gram. So that is gram molecular weight. That is called mole. So similarly here, gram equivalent weight is called equivalent. So you can call it equivalent. Please make a note, equivalent. Like mole, you can call it equivalent. And this is volume. Now let me further explain. This equivalent is nothing but, that is weight by gram equivalent weight of the solute. That is equivalent. Are you able to follow? Into 1 by V. This part is called equivalent. Like in the case of N2, you mentioned as weight by molecular weight. So here weight by, instead of molecular weight, you have to say gram equivalent weight. But what is gram equivalent weight? That is the molecular weight divided by valency factor. So that is equal to, that is, let me explain here, gram equivalent weight of the solute is equal to weight molar mass of the solute divided by valency factor. So you can replace this by M2 by E. Therefore it becomes W2 by M2 divided by E, that is reciprocated here. So E into 1 by V, or you can put 1 by V into E. Therefore N is equal to what? N is equal to W2 by M2 into 1 by V into E. We know already W2 by M2 into 1 by V is nothing but what? M, molarity, right? So we can replace this also. Now you can call it N is equal to M E. N அப்படி ஞாபகம் வச்சுக்கலாம். மீனா எனக்கு இல்லையா, N எனக்கு ஈஸியாக இருக்கும். So that is the relationship between normality and the molarity. So that is related by the valency factor. Okay. Most of the CBSE students, they handle by molarity, and state board students, they handle the equivalence, that is normality. So in practicals you may be using these units. So you should be very clear about this so that we can have the relation between this. You should be able to convert this also using this equation. So when you are given a normality, you can convert this into molarity by using the valency factor, which is called E. So what is E valency factor? Okay, I noted down. This valency factor is nothing but the, let me explain here. As far as an acid is concerned, it is called basicity. For example, let me say HCl. What is the valency factor? 1. H2SO4. What is the valency factor? 2. Phosphoric acid, H3PO4. The valency factor is 3. It means this talks about the number of bases with which it can combine. This is monobasic acid, hydrochloric acid, nitric acid. This can combine with 1 mole of sodium hydroxide, so that is why it's called monobasic. So the basicity is 1, which is nothing but the valency factor 1. And sulfuric acid is a dibasic acid, so the valency factor is 2. And phosphoric acid, the valency factor is 3, right? So H3PO4. And we have the acidic nature, you can call it acidity for the base, just opposite term. So in that case, for example, sodium hydroxide 1, is it not? Calcium hydroxide 2. And so this is for acid and this is for base. And we have the basicity, acidity, and in the case of salt, you can take the dominant valency. In the case of metal, you can take its valency straight away. Okay? This is for a metal. For a metal, we can take the valency straight away. Right? For example, what is the valency factor for hydrochloric acid? As I already told you, 1. Now, what is the equivalent mass of hydrochloric acid? That is, gram equivalent weight of hydrochloric acid is the molecular weight of hydrochloric acid is divided by valency factor. So HCl molecular weight how much? Chlorine 35.5 and this is hydrogen 1. So 36.5 divided by 1. So it means 36.5. Clear? For example, what is the gram equivalent mass of gram equivalent weight of sodium hydroxide? So sodium hydroxide is 40 molecular weight divided by valency factor 1. Suppose, let me work out for sulfuric acid. What is the molecular mass of sulfuric acid? MH2SO4 divided by valency of H2SO4, valency factor. So this is 98 divided by 2. So it is 40, right? Sulfuric acid, hydrogen 2, sulfur, hydrogen 1, but there are 2 hydrogen, and sulfur 32, oxygen 4. Means 64, is it not? So 98. Okay, so 98 divided by 2, that is 49 is the gram equivalent weight of what? Sulfuric acid. Is it clear? Right. And let me continue this molality, I mean mole fraction. This is called mole fraction. And this unit is, this symbol is termed as chi, C-H-I, chi, it should be pronounced as chi. So chi 2. Chi 2 is nothing but N2 by N1 plus N2. So what is N1? Number of moles of solvent. N2, number of moles of solute. So N1 plus N2, you can call it N, total number of solutions, molecules here. So N2 by N1 plus N2. Similarly, you can have chi 1 also. So N1 divided by N1 plus N2. Then molality. Molality is given by, it is M is equal to N2 by weight of the solution. Instead of liter, you can put weight of the solution. Here, volume. Molarity is volume. N2 by volume. So what is the unit of this one? For molarity, number of moles, that is mole per liter. You understand? So this is the unit of molarity. What is the unit of molality? Mole per kg. Are you able to follow? So it should be given in kg only. So since it is W, I can put 100 here, 1000 here, in order to convert the gram into kg. So you can have N2 by W1 into N2 by W into 1000. Okay. Let us consider this parts per million. So let me rewrite whatever I have written here in a very complicated manner. So molarity is given by, so here N2 by V, normality is given by, that is EQ2 divided by V, and molality is given by N2 by W. Of course, if you want to convert this into kg, you have to put multiply by 1000. Similarly, if it is given in ml, then it should be converted into liter by dividing by 1000. Divided by 1000 means you can reciprocate it, so multiplying by 1000. Okay. So here V is ml, here W is in gram. Okay. So remember all these things. This is mole. And what about mole fraction chi 2? That is N2 divided by N1 plus N2. So these are all the important formula you must remember. Then you have parts per million. Let me write here. Parts per million. It means, so what is the weight of this solute? Okay, what is the weight of solute in certain volume of solution into 10 power minus 6. Million means 6. Okay. Now let us summarize. There are various terms to express the concentration of solution. The percentage, molarity, normality, mole fraction, molality, parts per million. And for each we have definite formula, and we will work out some problems based on this. Now, you can note down in your question bank, calculate the weight percentage of sodium hydroxide of 50 gram dissolved and made up to 1 liter solution. So you should remember one important aspect. For example, if you want to prepare a fixed concentration, what you are supposed to do, you have to take a particular salt in a watch glass or in a paper, and that is the weight quantity, so you can call it a weight as a solute. Then you take a standard flask. This is called standard flask. You are used in your practicals, laboratory. So probably that is, it is given in a fixed volume, like 100 ml, 1000 ml, 500 ml. So here it is given as 1 liter. So this is 1 liter standard flask. You can find a marking here. So what you are supposed to do, you can transfer. Before that, you can pour the distilled water. So it has got here. Now what you are supposed, this is the first stage. You add distilled water and then add the salt as a second stage. Okay. So you can, the salt is dropped here and you can simply shake it and again add more water as in gradual level. Okay. So this is the water, that is the DM water or distilled water. So you have to, every time you have to dissolve it by mixing and make it up to this marking level. You should not exceed 1 liter. So this is the way you have to do it. You should not mistake that. For example, when I take this 50 gram of sodium chloride and take 1 liter, means 1000 ml. So I cannot take like this and add, there will be an increase or decrease in volume. That will mislead you. And that is why it is the common term which is very frequently used in the practical chemistry. Take a pinch of salt and weigh it, then the weighed salt is dissolved and made up to the required volume. So you have to understand this language. Make up to means that is the final volume. You cannot add 1 liter, not like that. You have to add some part quantity and make it up to the desired volume. Okay? So likewise, I have prepared this solution. I am interested to find out the percentage of this solution. So what is the formula? We have the formula here. That is, when it is not given as percentage, what type of percentage, it is understood it is weight by volume. So weight by volume. What is the weight by volume percentage formula? You have here W2 divided by V into 100. Okay, right. So this is in liter, ml. This is in gram. So what is W? Weight 50 gram. So put the unit also here and into 100 divided by, what about this volume? Volume is given in ml, is it not? So gram per ml into percentage. So 50 divided by, and this is 1 liter is equal to 1000 ml. So you should remember, you have to convert this. You cannot take it as 1 liter. Okay, this is 1 liter, but here it should be taken as 1000 ml. Okay, you cannot keep it as 1 liter because I already told you this volume in this formula is taken as ml only. So you have to convert this. Now you can cancel this, you can cancel this. So this is nothing but a 5% solution, weight by volume solution. Okay. So what is the percentage of solution, or you can mention as weight by volume percentage is 5%. Right? Now let me consider the next problem. Take down. Calculate the weight by weight percentage of 20 gram of a pigment 20 gram of a pigment is ground and dispersed with 980 gram of resin. When I say resin here, resin solution you can call it. Polymer. So I am preparing a paint like this. Paint is nothing but a pigmented varnish. Varnish is nothing but a resin, a polymer. So it is ground and dispersed. So here there is a difference in the term dispersion and dissolution. Dissolution means you take sodium chloride and dissolve it in water. You cannot see that sodium chloride. That leads to a true solution. Whereas when you take honey and grind some tablet and it is dispersed, then it is administered to the child for any medication. நம்ம சொல்லுவோம்ல சங்கு, இந்த சங்குல போட்டு மிக்ஸ் பண்ணி குழந்தைகளுக்கு கொடுப்போம் இல்லையா? That is called dispersion. Even paint is a dispersion. It's not a dissolution. So dispersion அப்படிங்கிறது it is different from the dissolution. It is something like a dispersion means that is அதோட பார்ட்டிகல் கொஞ்சம் பெட்டராக இருக்கும். இதில் இன்னொன்று இருக்குது, அதாவது டிஸ்பர்ஷன் வந்து சஸ்பென்ஷனாகவும் இருக்கலாம். அங்கே solute பார்ட்டிகல் கொஞ்சம் பிகராக இருக்கும். இந்த ரெண்டுத்துக்கு இன்பிட்வீனாக கொலாய்டல் டிஸ்பர்ஷன் இருக்குது. ஓகே, நம்ம அந்த சொல்யூஷன் டிஸ்கஸ் பண்ணுறப்போ இதை பற்றி டீட்டெயிலாக பண்ணி. ஓகே ரைட். இப்போ blood is a colloid. அதை நேரடியாக பார்க்க முடியாது நேக்கட் ஐஸில். ஆனால் மைக்ரோஸ்கோப்பிக்காக பார்த்தா it has got red blood corpuscles, white blood corpuscles, all are dissolved in water then. இல்லையா? அப்போது மைக்ரோஸ்கோப்பிக்காக பார்க்க முடிஞ்சதுனாக்கா அது colloidal dispersion. Whereas in between, அதாவது ரொம்ப பிகராக இருக்கிறது, இப்போ சேரு இருக்குன்னு வச்சுக்கோ, ஸ்லரி இல்லையா, அதெல்லாம் வந்து பார்த்தோன்னா சஸ்பென்ஷன். precipitate பார்த்தீங்கன்னா சஸ்பென்ஷன். curd is a suspension. நேக்கட் ஐயில் நம்ம கிளியராக பார்க்கலாம். அது அவ்வளோ ஹோமோஜீனியஸாகவும் இருக்காது. ரைட்? ஓகே, நெக்ஸ்ட். ஸோ we have to find out the weight by weight percentage. So what is the formula for weight by weight percentage? That is given as W2 divided by W into 100. So once again this should be in gram and this should be in gram. So this W is nothing but W1 plus W2, is it not? The total weight of the solution. So in that case, what we are supposed to do here, that is equal to 20 divided by 20 plus 980, how much? 1000. Got this one? So into 100, it means it has got 2%. So the weight by weight percent is 2%. So this is the way you have to calculate the weight by weight percentage. So such kind of calculations are used in drug and paint industries also. That is predominantly in paint industries they are using weight by weight percentage techniques. Then now let me move to weight by volume by volume percentage. Right? So I have certain liquid. Take down. I have taken say 200 ml milk, dissolved and made up to 1 liter with water. So what is the percentage of volume? That is volume by volume. Volume by volume percentage is volume of the solute. Here milk is the solute. Volume of the solution in ml into 100. So therefore this is 200 divided by volume of the solution 1 liter means 1000 ml. You should remember you have to convert this into 100. So you can strike out. So it means 20% volume by volume. Right? So the volume by volume percentage is 20. So in all these calculations, you could have noticed one important aspect. That is, nowhere we have used molecular weight. Is it not? And that is why in industries, among laborers, okay, these laborers, they can easily use this technique. Just simply by weighing or measuring, they can arrive at certain concentration. Okay? Right. Now, let us proceed with the calculation of molarity data. Question number 4. This is question number 3. Calculate the molarity of 5 grams of NaOH dissolved and made up to 200 ml solution. 200 ml solution. Now let us consider the molarity is given by M. So W2 divided by M2 into 1 by V. This is the formula. Okay. So what is W2? This is W2, weight of the solute. This is volume of the solution. Okay, that should be converted into what? Liter. So in that case, you can consider 200 divided by 1000. That is the volume. And you should be aware of the molecular weight of sodium hydroxide. So what is the molecular weight of sodium hydroxide? M2. M2 is different from M. That is molarity. M2 is molecular weight of that solute. So here sodium chloride, sodium hydroxide, sodium 23, oxygen 16, hydrogen 1, so totally 40. So 40 gram per mole. So molarity, molecular weight of sodium hydroxide is 40 gram per mole. Now if we take M is equal to, what is W2? W2 is given here as 5, and you should always mention the unit. So this is gram. So 5 gram divided by, what is the molar mass? Molecular weight is 40 gram per mole. So gram per mole, right? And then into 1 by, what is volume? This should be given in liter. So into 1 by liter. So this is 200 by 1000. So you can make it 1000 here, right? So this is 200 means 5 times. Am I right? Okay. So 5 5s are 25. Is that not? So 25 divided by 40. Okay. So that can be converted as 2.5 divided by 4. So that is equal to 0.6 4s are 24, balance 1, 2 4s are 8, and 5 4s are 20. So the molarity is 0.628, and it should be given along with the unit. So 0.625 gram. So you can cancel this gram. Okay, mole will go there. So mole inverse becomes mole per liter. So you can call it mole per liter. So this is the correct unit, right? Now let us work out the normality. Calculate the normality of sulfuric acid. calculate the normality of sulfuric acid of 9.8 gram dissolved and made up to 500 ml solution using water. So these are given. Let us calculate. What is the formula? Normality is given by equivalent of the solute divided by volume of the solution into volume of the solution. And if it is given in ml, and you have to consider 1000. Okay. So this is given in ml. Now, equivalent is nothing but weight by gram equivalent into 1000 by V. And W2 divided by gram equivalent weight is nothing but molecular mass divided by valency. You can bring it here divided by V into 1000. You can further elaborate. The valency factor is 2 for sulfuric acid because H2SO4. So there are 2 replaceable hydrogen here. So the weight of the solute is 9.8. This is gram divided by, what is the molar mass of the solute? Sulfuric acid is H2SO4, 98 gram per mole. So divided by gram per mole. And then here, what is the valency? The valency is 2 divided by, then what about this V that is given in what? Volume in liter. So here it is how much? 500 ml. So you can put 500 ml, but divided by 1000. So you can put 1000 here. Right? So this is 2 times. And here you can multiply and divide by 10. So it becomes 98 divided by 10 into 98 into 2 into 2, that is 4. Right? Now you can cancel this. So this is 10 by 4, it means, 4 by 10, 0.4. So the normality is 0.4, and you can mention this, and this is per liter, comes here liter, per liter, 1 by 10. And we know already this is E, means equivalent, this concept, this is equivalent. So you can call it 0.4 equivalent per liter. This is normality. Now, the normality can be converted into molarity. Let us work out a problem based on that. What is the normality of 5 mole of, or you can put 0.5 mole of oxalic acid? Okay. So what is the oxalic acid? It is given as H2C2O4. But when you look at this as laboratory reagent, along with that you have 2 moles of water. Okay. So actually this is oxalic acid dihydrate. So let us work out the molecular weight for this H2, 2, carbon 2 into 12, 24, oxygen 6, 16 into 4, 64, 2 moles of water, 36. So it comes to how much? This is 64 plus 2, 68, 24, 4 plus 4, 8, and then this is 88 and this is 90, 126. Okay. Now this 126 gram per mole is the molecular weight. Now let us have what is the question asked? The normality is asked. So here we can have the N is equal to ME. You can make use of this formula straight away. So M is equal to 0.5. So 0.5. Valency factor, here it has got 2 replaceable hydrogen. So dibasic acid. And not only that, sometimes it is given based on the oxidizing agent also. So a valency factor can also be represented in terms of number of electrons transferred in the oxidation or reduction. In the case of reducing agent and oxidizing agent. That I have missed that one, you can include. Under a valency factor you can put for reducing and oxidizing agents, you can consider the number of electrons transferred during its oxidation and reduction process. Okay. So in this case, we have to consider 2 electrons that is transferred here. So you can put into 2. So it means 1. So in normality of oxalic acid, it is 1. Okay. And most frequently in your laboratory methods of preparation as well as analysis like volumetric analysis by titration, you may be using this KMnO4. What is the color of KMnO4? Potassium permanganate. Okay, it is purple in color, right? And let us work out the normality of KMnO4. How to calculate this? So the molecular weight of potassium permanganate is 158 gram per mole. Okay. So I am taking, say that is 1.58 gram and dissolve in, say about 100 ml water, made up to 100 ml solution. So this is W2, this is volume of the solution. So let us calculate the normality of KMnO4. What is that? That is the equivalent of KMnO4. So equivalent of KMnO4. So first of all we have to calculate the equivalent of KMnO4 divided by volume of the solution. Okay. And then equivalent means that is molecular weight divided by molecular weight by molecular weight. W2 by M2 into E by V into, and you can divide it by 1000 means into 1000. Okay. So that is equal to, here W2 is how much? 1.58 divided by molecular weight is 158 into valency factor here for potassium permanganate is, in this case you have to take the number of electrons transferred here. Okay. So usually this is in the stage +7. When it is, this is oxidizing agent. Naturally oxidizing agent undergoes reduction. So during reduction, this M1 plus 7 becomes M1 plus 2 using acidified KMnO4 and H2C2O4. So in that case, it gives what? The reduction. So this is reduction because decrease in what? The oxidation number. So it involves 5 electrons here. So 5 electrons are added. And that 5 electron is taken into account here. Are you able to follow? And that is why it is given as what? Now you have got equivalent weight, that is W2 divided by molecular weight. The valency factor is 5. So you should understand why I have taken 5. Is it clear? Because the number of electrons transferred in the reduction process. Divided by the volume. What is the volume we have considered? 100 ml of the solution. 100 ml means liter divided by 1000. Okay. So now you can work out and find out the normality. Can you get me? So you please give your answer in the comment below. And with this, let me complete the expressions of concentrations of solutions. Right? So if you've got any doubt, you can contact